was supposed to be the guy between you and your lunch, and turns out I'm the guy that is supposed to keep you awake. So hopefully I'll make it. I don't promise anything. I'm falling asleep as well. So hello everyone. Good afternoon. This talk is all about queuing and notification service made by and for OpenStack. It's all about Marconi. It's a pretty new project. It's been around for a year and a half or something like that. So what we're going to do today, we're going to go through the why, what, and how Marconi. We're going to talk a little bit about the architecture, and we're going to really give a high-level overview of how you would deploy Marconi and why you would use it, and some of the use cases we have right now for Marconi. This is me, very quickly. That's my Twitter handler. Everything you want to know about me is probably already up there. I work for Red Hat, in case you didn't notice it. And I'm part of the RDK community, and we are the ones that make sure OpenStack works perfectly on every single Rails-based distribution out there. Either it is Rails itself, Fedora, CentOS, or any of other distributions. A few other things about me. I'm not going to go through all of these, but definitely I want to mention I'm part of the Google Summer of Code Mentors and the Outreach Program for Women Mentorship Program. And if you're not part of those, I really encourage you to be part of them. We need more mentors. We need people teaching others how to be good developers in the OpenStack community, or in other projects. So why Marconi? First and foremost, because we want services intercommunication. Services intercommunications is really important. We have been talking about cloud providers, cloud systems. We have been talking about services running in distributed physical machines throughout your infrastructure. We have been talking about several OpenStack services, but we haven't mentioned yet how those services actually interact with each other. There are different levels of interactions. Marconi definitely wants to cover one of those levels, and it's definitely not the lowest one, but Marconi wants to be part of what your undercloud and overcloud is. Because it was a missing piece in OpenStack. In OpenStack, we didn't have a way to have a queuing service, so a way to sell queues to other users. Because lightweight messages are important, and we want to have a way to integrate services by sending with a simple API, with a very simple API, sending small messages throughout your infrastructure, and without any extra cost to your infrastructure, to your deployment. So you would use all your technologies that you're probably already using, and you will put Marconi on top of those technologies, and you will still have a queuing service. You will still have a queuing infrastructure, but you will have a service on top of that infrastructure. Because we want to have a messaging service, and it is less oriented to queuing services, so queues are still there, but are not the main resource we have in Marconi. The main resource and the most important resource in Marconi is our messages, and that's basically all what we care about. And something went wrong. So Impress just died. And because we wanted to have notifications in OpenStack as well, and having a way to have notifications flying around without having to plug services in the underlying, to the underlying messaging layer that we have, which is basically based on brokers, NQP brokers for now. So before going through what Marconi is, I really want to mention what Marconi is not. Marconi is not a replacement for RabbitMQ, Qpid, or ZeroMQ. What Marconi wants to do is sit on top of those technologies and allow you to have a very nice API on top of those technologies without you having to replace them in your infrastructure. It's not a task manager, nor a workflow engine. So Marconi is not a replacement for Celery, in case you already know what Celery is. Marconi can actually be used, but it can actually be consumed by Celery. So there's actually a transport, a combo transport for Marconi already out there. So you could probably use Celery and make it talk to Marconi. And it's not a queue provisioning service. So with Marconi, you're not going to install RabbitMQ. With Marconi, you're not going to just create queues in your RabbitMQ and your deploy RabbitMQ. With Marconi, you will actually use RabbitMQ through Marconi. So what is Marconi? Marconi is akin to SQS and SNS. So there are two services from AWS, and I really hate comparing it with AWS, but it is out there, and those services exist. And Marconi is akin to those services. In AWS, you have two separate services. One is SQS, and the other one is SNS. The first one is simple queue service, and it just gives you queues. And the second one gives you notifications. In Marconi, we truly believe those two services are related, really related to each other, and that by providing them in a single service, in a single application, each one of them can benefit from each other by living on the same code base, on the same service. So Marconi is both of those services living in the single service. Marconi is a data API. So I probably already mentioned this. So Marconi is not a provision API, it's a data API. All the data traveling through Marconi's API is actual data, and it will be sent to your underlying technology, whether it is QP, RabbitMQ, or whatever you're using, a database, I don't know. But it's all based in data. As of now, it just has an HTTP transport, so it just has an HTTP API. That's what you would use, just like SQS has. But there's already the infrastructure needed to have different transports in Marconi. So you could probably have a TCP transport or something else. So whatever protocol you think is useful or important for your infrastructure to have. It unifies technologies in terms of, it won't just sit on top of your existing technologies, but you can also have several of them deployed at the same time, different technologies. Like you could have RabbitMQ and MongoDB and other, I don't know, technology that you would want to use with Marconi, and you can put Marconi on top of those trees and use the three of them at the same time based on your needs. And it borrows semantics from queuing systems. And obviously, it's a queuing service, so it wants to be as similar as possible to existing queuing services. And it doesn't want to introduce new concepts and change the way people is already used to work with queuing systems. So as of now, as of now, Marconi just provides queues, messages, and claims. I already mentioned that queues are lazy resources. So in order to post a message, you don't actually have to create a queue. You just can post a message to a queue. But if you want to create a queue and have customize that queue in terms of messages, TDL, or what storage that queue should be stored in, etc., you can do it. And it has claims. Claims is the way you would lock a set of messages so that your workers can work on those. And claims have TDLs as well. So very quickly, Marconi's architecture. So it's very simple. It's based on 3 different layers: a transport layer, an API layer, and a storage layer. The transport layer is the one that actually the clients talk to. And as of now, you already mentioned we have just an HTTP transport, but you could also have a DRAM-Q transport or a TCP transport if you want. That's likely not going to happen during Juno, but we're targeting to have a TCP transport during the K release, hopefully. But you don't have to limit yourself just to those perhaps lower level protocols. You could also have a MQTT transport in order to provide notifications to your mobile phones and other clients around the world. The second layer is the API layer, and it's the one that defines basically all the API. The reason why we have this layer here is because we wanted to remove all that logic from the transport layer, so that people implementing new transport just have to care about implementing the transport itself, so just the protocol itself, instead of worrying about the API. So this API layer is just an interface between the transport and the storage layer. And then we have the storage layer. The storage layer is the actual technologies that you probably already have deployed in your infrastructure. As of now, we have 2 storage drivers. One is the MongoDB one, and the second one is an SQL Alchemy-based one. And although I really don't recommend using SQL databases for queuing services, it is there, and one of the main purposes of these drivers is to allow us to develop Marconi easily, because we can use SQLite. But the driver we recommend for production environments is MongoDB, and is actually already deployed in Rackspace Cloud Service. There are several reasons why we started with MongoDB and we didn't start with an MQP broker. I'm not going to go through all those motivations right now, so if you are interested, we can talk afterwards. But something to consider about this architecture is that Marconi is 99.9% composable, so you can play with it like if it were like Lego bricks. You just pick the technologies you want to deploy in your infrastructure, your storage technologies. You pick the transports you want to have deployed in your infrastructure, and you just deploy them. It is obviously plugin based in order to have that. And I mentioned the two transports and the two layers we have right now, transports and storage. The transports we have are HTTP, and we are targeting the TCP for the K release. The HTTP transport uses Falcon framework, and it doesn't ship any container, any WSGI container. So it just ships on a WSGI application so that you could choose whatever container you want to use in your deployment. Either it is micro WSGI or Unicorn, you're free to choose whatever you want. But it does run perfectly on WSGI ref, which is the WSGI container, the toy WSGI container that you have in your Python standard library, which we obviously don't recommend for production environments. In the storage layer, we have MongoDB. I already mentioned SQL Alchemy, but I really don't recommend having SQL databases, queuing system running on top of SQL databases. And what we're working on right now is an AMQP 1.0 storage driver for Marconi, so that we will be able to support several different brokers that are capable of speaking AMQP 1.0 at the same time. And we're also working on the Redis driver for Marconi as we speak. All that hopefully will be released during the June release. The authentication methods you have in Marconi right now are basic HTTP and Keystone based. If you use Keystone, you obviously have all the multi-tenancy features that it provides, and you can have well, different projects, organizations, or tenants using the same Marconi installation, Marconi deployment. If you don't use the Keystone authentication method, you can have multi-tenancy, but you have to do it manually by passing the tenant name. But you can still use basic HTTP if you want. And if you want to use your own custom authentication method, you can also do that. You just have to write a plugin in order to Marconi to be able to talk to that authentication method. So that's Marconi's architecture. That's a really high-level overview of what Marconi looked like from a developer perspective. We can now go through the different deployments methods that you have with Marconi, so how you can actually install Marconi and use it in your deployment. One way to do that is by having single storage Marconi's deployment, and that is basically several Marconi nodes running in parallel in your infrastructure on top of a single storage cluster. And a storage cluster, you already mentioned it, a storage cluster could be a MongoDB replica set, your MySQL cluster if you want to use MySQL, your Redis cluster if you want to use Redis, or whatever broker, AMQP broker cluster if you want to use an AMQP broker. But it will run just on top of a single installation of those technology. Another way to deploy Marconi is by still having several nodes of Marconi running on your infrastructure, but sitting on top of several different storage clusters that you also have running in your infrastructure. We call these, so sharded is actually such an overloaded term here, and there are many storage technologies already using this term, so we are already changing it to pools. And what we consider a storage pool is, like I said, is a storage cluster of whatever type you chose to use in your infrastructure. It could be a MongoDB replica set, it could be an MQP broker cluster, or a Redis cluster if you want. You can configure Marconi to talk to them, and to do that in a queue basis. So basically you tell Marconi to route your queue's messages to a specific storage cluster based on the queue name or the queue properties. And you do this based on your application needs, and what's the throughput for that queue, or what's the throughput that you actually expect to have in that queue, and whether you want that queue to be fully durable, or you want that queue to be always in memory or whatsoever. So you basically choose your storage cluster or where your queues should be stored based on those properties. And there's one more thing to consider when you're deploying Marconi. And it's the fact that you can also deploy Marconi with several different transports. And you can have several HTTP nodes running one next to each other. You can have several TCP nodes running one next to each other, or have a mix of those. You can have private nodes that expose the HTTP admin API. And you obviously can have HA proxies on top of those nodes if you want to scale them out. Or you can also provide the direct address to those nodes to your application. Something important though to mention is that all these nodes are actual independent nodes that can be anywhere in your infrastructure and based obviously on your scale needs. So now let's go to some of the probably more interesting things about Marconi, I hope. And one of the things that Marconi provides FIFO, it guarantees FIFO, which is something that you don't have in SQS. And well, it actually depends on the storage cluster you're using. And since the pools are configured in a queue basis, we can still guarantee FIFO in a per queue basis, because we will store all messages for a specific queue in the same storage. And not all storage allows to guarantee this, so it always depends on the storage you choose to use for Marconi. It has storage partitions, and we barely talked about this. Something interesting about the storage partition is that, so the implementation so far is very simple, so it doesn't allow you to do really fancy things, but we're working on new things to take the most out of those storage partitions. But it definitely allows you to have and to use different technologies, different queuing technologies or storage technologies with your Marconi deployment, and in a very easy way. And one more thing that is actually interesting about this is that you can start by, I mean, if you don't have anything actually deployed on your infrastructure and you install Marconi and deploy, I don't know, RabbitMQ, and then you figure out that RabbitMQ is not the best thing for you and you prefer to use something else, I don't know, a database or another MQP broker, you can swap those and you don't have to change the code in your application. So you have this higher level API that is unifying all those technologies so that you don't have to change everything in there. It fits in your stack in terms of, and again, it wants to be very lightweight so that you can just install Marconi and you don't have to change everything in your application, in your infrastructure, sorry. So it fits perfectly in your stack because it wants to play nice with whatever you're using right now. And if there's not support to the technology you actually have deployed in your infrastructure, you can obviously write a plugin for it, and it can live outside Marconi's code base. It doesn't have to live in there, and you can always use it and consume it. It is easy to scale Marconi, and I'm not talking here about the underlying technology that you're using. Marconi itself is very easy to scale. You just have to add more nodes in your infrastructure. It is always, so scaling your broker will always be an issue for you. And despite that, many people say that broker scaling is already fixed and you can now create clusters of brokers and have them running in your infrastructure. That might be true, but that's still very hard to do. So that will still be an issue. But the nice thing is that you can have several of those clusters deployed in your infrastructure, and Marconi will talk to them. I already mentioned the unified API. There's a really nice HKCD stripe that I didn't put here. It basically says that in order to fix the problem that we have 14 different APIs, we have to create a new API that sits on top of all of them. We basically did that for Marconi, despite that we obviously didn't want to create yet another standard or yet another API that people have to learn. But we did it And the main reason is because we wanted to fix all the problems related to scaling your messaging infrastructure. One more thing to say about Marconi is that it is service-oriented in terms of it tries to apply NAS to whatever service you're running in your infrastructure. Either it is on the under cloud or the over cloud. I already said that Marconi is not a replacement for RabbitMQ or Qpid, but it definitely can be used by other services in OpenStack, and that's probably going to happen in the next release. And these are some of the use cases we're targeting right now. One of the use cases is Horizon's notification. So every time you use Horizon, you get a pop-up when you run an instance and the instance fails to start or succeeds, you get a notification. So some of the things we have talked to the guys from the Horizon team is that it would be really nice to have Marconi do that instead of they consuming messages and notifications from the underlying queuing system. This is definitely something we want to do during the Juno release. And the same thing will happen with Ceilometer. This is something interesting in the Ceilometer use case because Ceilometer basically plugs into your AMQP broker and the AMQP broker you have deployed, and it consumes all the notifications and messages that are going through that broker, and it generates events and stats based on those notifications. But when something changes in those notifications, Ceilometer is basically broken, right? Because it won't be able to parse the message. By talking with the Ceilometer guys, we realized that we could probably take that burden out of them and basically do it in Marconi. So if something goes wrong with the broker, Marconi will be broken. But anyway, what we are going to do, we will have the same plug that Ceilometer has, and we will consume all messages from Ceilometer, and we will generate new notifications out of those messages, either using webhooks or other pushing protocols or technologies. We haven't figured out that yet, but that's going to definitely happen. Another use case, interesting use case, is having guest agents intercommunication based on Marconi. So this is, we have talked about this with guys from the Heat team and the Trove team. So basically, they always, I mean, when you use, especially Trove, well, Heat as well. When you use those services and you run a new instance or you have something running in the instance, as far as I understood, they have guest agents running in the instance itself. And one of the issues they have is that when something happens in those guest agents, in those instances, they don't have a really nice way to notify all the other instances or the service or the service itself about what's happening there. So one use case is to use Marconi for that, and have the guest agent talk to Marconi about what's happening in the instance, and then Marconi notify and broadcast the message to all the instances. So use cases like this, the reason why I mentioned these use cases is not that because they are the most exciting ones, but they're definitely exciting for us as a team and as a project, but because there are several other use cases out there for the overcloud that are similar to these ones. So if you have similar use cases, you probably could already use Marconi. And if you're already using SQS or Simple Queue service, you can definitely use Marconi already. So, and before closing, I wanted to mention 4 things that we have in the roadmap for the Juno release. One of those is queue flavors. Queue flavors are basically the same thing as Nova flavors, compute flavors. So in compute flavors, you have the configuration for your instances. In the queue flavors, you will have the configuration for your queues. When you create a queue and you select a flavor for that queue, you can choose whether the queue has to be durable or the queue has to be always in memory, and whether you have a really high throughput for that specific queue. And Marconi will pick one storage cluster for you based on those configurations. So if you always want to have your messages in memory and you don't care about anything else, it will probably pick a Redis storage if you obviously have it deployed. If you have a really high throughput, it will probably pick your AMQP 1.0 storage driver. And if you want your messages to stay around for a long time, it will probably pick the MongoDB storage driver if you have it deployed, obviously. So it's pretty much the same way Nova flavors work. We're working on a queue single pool live migration. So Marconi already has a way and I think this is the fifth time I say this, Marconi has already a way to have partitions, pools, Marconi pools. But when one of those pools, when one of those queues turns out to be a really write-heavy or read-heavy queue, and it's basically killing your storage pool, you probably want to migrate that queue to another storage pool, or migrate the other queues that you have in that pool to another storage pool. It's not possible to do it right now, but we're working on this queue live migration from a storage pool to another storage pool of the same type. So you would migrate queues from a MongoDB storage pool to another MongoDB storage pool, and without any downtime. We're working on the MQP and Redis support for Marconi. And we're definitely working on more serious benchmarks than what we have right now. We already did some benchmarking as part of the incubation deployment. But those were mostly based on the current status of the project and the deployment evolution of the project. And since there's already a production environment using Marconi and these rack service queues, we probably have some benchmarks based on their use case and how they're using it. And that's it. So one of the things I really wanted to do with this talk is clarify some of the concepts and doubts that are behind Marconi in the community and what we're trying to do with Marconi itself. I purposely didn't went through the whole API and the semantic tree support. There's a lot of documentation about that upstream that you could go and read if you are interested in using the API. But I hope that after running through my talk, you have a clearer view of what Marconi is targeting and what we're doing with the project. And hopefully you have already some use cases. And if you do, please come afterwards and talk to me. And just to end, we're hiring. If you're interested in working for Red Hat, please come to me and we'll talk afterwards. Thank you very much. Are there any questions? Go ahead. Yeah, so the question is, can you run Marconi as a standalone service? Yes, you can. Marconi does not depend on other OpenStack services. So you can just deploy Marconi on top of whatever technology you're using. And obviously, if you want to use Keystone, you have to install Keystone. But if you don't care about Keystone, you can deploy Marconi without it. Any other questions? There don't seem to be any. OK, there's him. Can you speak louder, please? Sorry.
Would it make sense to, I don't know, since OpenStack itself relies on an underlying messaging service, would it make sense to expose to implement some isolation inside that messaging service and have a portion exposed to higher levels of the stack to act as either as a basis for Marconi or as an alternative to it?
So let me see if I understood your question. You're basically saying, since OpenStack already has a NQP broker deployed, would it make sense to use that same broker? Yeah, definitely. If you isolate your broker, then yes, it would make sense. If you want to use the same broker as you are using it in OpenStack and you want to put Marconi on top of that, I wouldn't probably do that. I mean, there is probably a whole security there that you don't want to have. But if you isolated it, then yes, it would definitely make sense. Are there any other questions? OK, thank you very much.